In the previous video, we talked about how important equations are in our daily life. Now, we need to be able to represent equations in graphs. Now, in CA, almost of all the equations are linear equations with two variables. This is the only type we are going to encounter. There may be another type of equations also, but those type of equations do not often repeat themselves. The only type of equation that often repeats are linear equation with two variables. Now, what is meant by this? Linear means the power will be 1, power of the equation will be 1, maximum power of the equation will be 1, and two variables means there will be two variables, x and y, for example. Before going to directly to the graphs, let's take a problem and then convert that problem into equation and then try to represent that equation into the graph. Representing problems in equation, first of all. Now, this is the problem we have with us right now. See, if you attend all classes and listen to them carefully, then you can score 30% of the marks in the exam. Okay, so this means that if you attend the classes and then listen to them carefully, this is the main thing, listening to them carefully, then you will be able to get 30% of the marks in the exam. Now, what this means is, after listening to the classes, you are going to go to the exam directly without even studying anything, without studying even for 1 hour, without revising anything. If you just listen to the classes and go and write your exams, then you will get 30% of the marks in the exam. And to get additional marks, you need to study. You need to study, right, to get the additional marks. And for each hour spent on studying, you will get 0.5 marks on an average. Okay, so what this means is that you have to attend lectures and then listen to them carefully. If you attend and listen to them carefully, then you will get 30% of the marks in the exam. Now, to get additional marks more than that 30%, then you need to study on your own. Now, while studying, each hour you spent on studying, you will be able to get additional 0.5 marks on an average. Like maybe for each subject, you will have different capacity, right? Maybe in one subject, you may be able to study with less time. You may be able to study less time and get more marks. And there may be another subject where you will need to study more hours and also get very little marks. So we are taking an average across all the subjects. So based on the average, you will be able to get per hour of studying 0.5 marks on an average. Now, the maximum marks in each subject is 100 marks. Okay. Now, we need to represent this problem in an equation. This is not a problem. This is just a scenario. Now, any scenario, in the previous video also I told you, right? Every scenario can be represented in an equation and every equation can be represented in a graph. Okay. Now, here in this scenario, there are two variables. You remember the importance of variables, right? I truly recommend to watch that video once again if you hadn't watched it. Now, what are the variables in this scenario? The variables are the number of hours you are going to study. That will be my x. Let's take that as x because you don't know how many hours you are going to spend studying in the subject. You may be able to spend only 10 hours, and for 10 hours you will be able to get for each hour 0.5, that is 5 additional marks than the 30% of marks you are going to get listening to the lectures. And also there is one more variable, that is the marks you are going to score. Let's represent that marks as y. Now, these two are the variables. Even though we have two variables, they don't have similar properties because x is the number of hours you are going to study and y is the number of marks you are going to score. Now y value will depend upon the x. If you study more hours, then you are going to get more marks. Okay, so y value will depend upon the x value. If x is 10, then y will increase by 5 marks, because 10 into 5, 10 into 0.5, for every hour he is going to get 0.5, right? So he will get 5 additional marks. So here x is a independent variable. That is you can study as many number of hours you want. And y is a dependent variable. Dependent on what? On the number of hours you are going to study. And x is an independent variable, because it is this value, the x value is not dependent on anything. It can have value on its own, and y value is dependent upon the number of hours you are going to study. That's why these two have different properties. Even though they are variables in an equation, but they have different properties. Variables are y is equal to marks scored and x is equal to number of hours studied. Y will be dependent variable and x will be independent variable. Now the equation will be, we are trying to find out the marks you are going to get, right? Now we, from the perspective of the marks you are going to get, the equation will be y is equal to 30 plus 0.5 into x. Why? Because y is equal to 30. Let's forget about this part of the equation. First of all, focus on only 30. Y is equal to 30 because even though if you don't study even for a single minute, you are going to get a 30 marks in the exam, assuming that you attended all the classes and also listen to them very carefully. That is the basic assumption here we are taking. And if you did that, then the minimum marks you are going to get in each subject is 30 marks. So whether you studied or not, whether x is 0 or whether x is 500 also, x value can be anything. Y will have a minimum value of 30. So y will be 30 plus 30 plus whatever number of hours you spend studying into the number of marks you are going to score per hour of studying. That is 0.5. Let's cross verify this equation here. If you studied 50 hours, then you will be able to get 0.5 for each and every hour you spend studying. So for each and every hour you spend studying means 50 into 0.5, that is equal to 25 marks. So for listening to the classes, you got 30 marks, and for studying additional 50 hours, you got 25 marks. So the total marks you will get is 55 marks. So this is the equation. Now we got this equation. Now we need to be able to represent this equation in a graph. Now let's represent this equation in a graph here. Here the x-axis and y-axis is divided into 15 intervals of each. I mean, x-axis represents the number of hours you are going to study, and each centimeter represents 15 hours of studying. Okay, and also y-axis represents marks you are going to get, and each centimeter represents 15 marks you are going to get additionally. So here we need to plot our graph. To represent this equation in the graph, there are some steps we need to follow. First of all, we need to simplify this equation. How do we simplify it? We need to get all the variables to one side of the equation and all the constants to the another side of the equation. Now, if we take this 0.5x to the left hand side, then the equation will be y minus 0.5x is equal to 30. After simplifying the equation, we need to find the points where the line meets x-axis and y-axis. Because when the point is on y-axis, then x will have value of 0. When the point is on x-axis, y will have a value of 0. So we need to find the value of x when the value of y is equal to 0. And also we need to find value of y when the value of x is equal to 0. What will be the value of y when x is equal to 0? Y minus 0.5 into 0 is equal to 30. So this whole thing will become 0, y is equal to 30. So the line is going to intercept at 30. The line is going to intercept here. In the same way, we need to find the point where the line is going to intercept on x-axis. When the line is intercepting on x-axis, then y will have a value of 0. Because when the point is in here, y will not have any value, right? So we need to find a value when y is equal to 0. So if we substitute 0, then 0 minus 0.5x is equal to 30. X is equal to minus 30 divided by 0.5. X is equal to minus 60. So the line, the graph line, the slope is going to intercept x-axis at 30 and y-axis at minus 60. Okay, so when we connect these 2 points in a straight line and extend that straight line into the first quadrant, then we will be having that graph. So this is the graph here. Now what this line represents is that it represents every possible outcome of the problem. Now let's say, for example, you want to find out the number of marks you are going to get if you studied for 70 hours. Then what you need to do is you need to find a point of 70 on the x-axis. 70 will be here. Now you need to extend that point until the slope. If you extend the line until the slope, then the line will be like this. Now to this point, you need to extend to the y-axis also. If you extend to until y-axis, then you will get. So the marks you are going to get is the point on y-axis is 65. So if you studied for 70 hours, then you are going to get 65 marks. Now we need to check whether this is right or not. Y is equal to 30 plus, our equation is y is equal to 30 plus 0.5x, right? Now we need to substitute 70 hours in x. Then y will be 30 plus 0.5 into 70. Then y is equal to 30 plus 35. Y is equal to 65. So like this, you can find out the answers for any combination you want. So let's say, for example, you want to find out how many marks you are going to get if you studied for 90 hours. If you studied for 90 hours, then what you need to do is you need to extend from y-axis until the slope. You need to extend a line from x-axis to slope, and then at that point, from that point, you need to extend the line until y-axis. Wherever the point meets on the y-axis, then that point will be your answer. Then you are going to get 75 marks. So what this means is, if you studied for 90 hours, then you are going to get 75 marks. In the same way, if you want to find out how many hours you need to study to get 100 marks, then first of all you need to find where the 100 is on y-axis. The 100 will be here. From here, you need to extend the line until the slope, until where that point meets the slope. Now from here you need to connect the x-axis. X-axis will be until here. Here the point is 140. So you need to study 140 hours to get 100 marks. If you want to cross verify it, we can cross verify. The equation is y is equal to 30 plus 0.5x, right? Now we need to get 100 marks. Then y will be 100. We need to know how many hours I need to study. Then 100 is equal to 30 plus 0.5x. Then we need to send this 30 to the left hand side of the equation. Then 100 minus 30 is equal to 0.5x. Then 70 is equal to 0.5x, and if you send this 0.5 to the left hand side of the equation, then x will be 70 divided by 0.5 and x is equal to 140 hours. Now we got this line here. Now what is the use of this line, you may ask. Now let's say, for example, we have the equation, right? What is the equation? Let's say you want to find out how many marks you are going to get if you studied for 70 hours. Then what will you do? You will substitute 70 in the place of x and find out the y value. What will be the y value then? 70 is equal to 30 plus 0.5 into 70. So y will be 30 plus 35, y is equal to 65. So this is the process you followed. And if you want to find out how many marks you are going to get if you studied for 90 hours, then what will be the solution? Then again you need to substitute that 90 in the place of x. Then y is equal to 30 plus 0.5 into 90. That is equal to y is equal to 30 plus 45. Y will be 75 marks. So to get, if you studied for 70 marks, you can get 65. If you studied for 70 hours, then you can get 65 marks. In the same way, if you studied for 90 hours, then you can get 75 marks. So what if you want to get 80 marks in the exam? 80. What if you want to get 80 marks in the exam? So based on this, your, say for example, say for example, you kept a target of 80 marks. You want 80 marks in that subject. Now you want to find out how many hours you want to study. Now what will you do? You will substitute 80 in the place of y. Then the equation will be 80 is equal to 30 plus 0.5x. Now this 30, you need to bring this 30 to the left hand side of the equation. 80 minus 30 is equal to 0.5x. Then 80 minus 30 will be 50. That is equal to 0.5x. And here 0.5 is in multiplication. And if you send that 0.5 to the left hand side, then it will be in division. So x is equal to 50 divided by 0.5. So x will be 100 hours. So to get 80 marks, you need to study for 100 hours. Like this, for each and every possible outcome, you need to repeat this process to find out the number of marks you are going to get for each hour you are going to study. And also you need to follow this process to know how many hours you need to study to get the specified number of marks. Now, what this slope represents is that you can visualize every possible outcome of the situation here. Say if you want to get 40 marks, then you need to study for 20 hours. If you want to get 100 marks, then you need to study for 140 hours. If you studied for, say for example, 120 hours, then how many marks you are going to get? Then what you need to do is, you need to just from 120 you need to extend the line to the slope, and then from there you need to extend the line to the y-axis. Then wherever the point meets the y-axis, then that will be my answer. You don't need to substitute values in this equation to get the answer here. So the graph helps us to get a overview of the situation. You will be able to see every possible outcome at a glance here. If you just have this equation, then you will not be able to get this much clarity over the problem. Because if you just had that equation, you will not be able to tell me how many marks I will get if I studied for 80 hours. To know the answer, you need to calculate it. And also, if I asked you for another number of hours, say for example 200 hours, then you need to again calculate how many marks you need to get by substituting the values in the equation. But when you have a graph, then you will have at your disposal every possible outcome of the problem. Just by seeing this, you will get to know how many marks you will get if you studied for 60 hours. And you just need to, in your mind, you just need to connect these 2 points. That's it. Now, this is one of the benefit of representing an equation in a graph. That is, you will be able to visualize each and every possible outcome of the problem. Like, for example, here, you are able to visualize how many marks you are going to get if you studied for 120 hours without even calculating the thing, calculating the value by substituting values in the equation. Every possible outcome, you can visualize it here. Now, the other benefit to representing an equation in a graph is that we will be able to understand the relationship between coefficients of x and y. Now, our equation is y is equal to 30 plus 0.5x, right? Here, the coefficients of y is 1 and the coefficient of x is 0.5. Now, what this means is that if x is increased by 1, then y will be increased by 0.5. See, if we observe here x is increased by 15, from 0 to 15, and y is increased by 30 to 37.5. So there is an increment of 50%. There is an increment of 0.5. X is increased by 15 and y is increased by 7.5. That means y is increased at 0.5 of x. Okay. So if x is increased by 15, then y will increased by 7.5. This is the relationship between coefficients. Let's take another example where the coefficient of x is 2. Then equation will be y is equal to 30 plus 2x. Then what happens? The coefficient of y is 1 and coefficient of x is equal to 2. Here, for every 1 unit of increase in x, the y will be increased by 2. That means if you study for 1 hour, you will get 2 marks. Okay. If we see in a graph here, if we represent that equation in a graph, what happens is that if you represent y is equal to 30 plus 2x in a graph format, then the graph will be like this. Okay. Here, from 0 to 10, x has increased by 10. If you extend the line from 10 to the slope, then it will meet y-axis at 50. Here, x-axis is increased by 10 and y-axis is increased by 20. So what this means is that here for every increase in x, that is x is increased by 10, y will be increased by 2. So if x is at 10, then y will be at 20. The angle of slope depends on the coefficients of x and y variable. If the coefficient of x and y is 1, what will happen then? From here, from 32, for every increase of x in 1, and y will also increase by 1. So the slope will be like this. Okay. If the slope starts from 0, then it will go like this. Okay. X will be increased by the same amount as y. They both increase at the same rate. Now the final concept in linear equations is the error term. What is this error term? In the equation, we got an equation like this. Y is equal to 30 plus 0.5x, right? Here all of these are assumptions. We have assumed that I will get a 30% of the marks because I studied, and I will be able to get 0.5 marks for each hour I study. So these are my assumptions. What I assumed and what actually happened may be different. They both may not be same. Because of these differences between my assumptions and what actually happens, we can say that there is an error in this equation. To account for that error, we will include an error term. error term. Now the equation will be y is equal to 30 plus 0.5 x plus error term, this term. Why we account this is because maybe you studied for only 20 hours. Before this error term, your predicted marks was y is equal to 30 plus 0.5 into 20, y is equal to 30 plus 10, y is equal to 40. What if you got 45? What if your marks was 45? Then this equation is wrong, right? So to avoid this, we will include an error term here. What this error term is that the difference between what we predicted and the actual value will be my error term. So in here, if the outcome is 45, then my error term value will be 5. If we include the error term, the graph will be like this. Say for example, there are 5, we have predicted this for 5 students, and for all those 5 students, one student has studied for 30 hours and what he should have got was 45 marks, but maybe he got 50 marks. So I should represent that error term here. I will make a point here and I will connect these two. Maybe another student was there, he studied for 75 hours, and what he should have got as per the prediction, he should have got 67.5. But here, maybe he got 80 marks. So what I need to do is, I need to make a point at 80 and connect these two lines. And also maybe some other person is there, he studied for 120 hours, he should have got 90 marks, but instead of getting 90 marks, he scored only 60 marks. So what I will do is, I will make a point at 60 and I will connect these two, the slope and this point, this 90 marks. What I am doing here is that I am correcting my equation by including an error term and using this data to make future predictions. Now I will conclude the whole thing. Every equation can be represented in a graph like this. To represent an equation in a graph, we need to follow certain steps. Those steps are, first we need to simplify the equation, and then we need to find the points where that slope will meet x-axis and y-axis, and we need to connect these 2 points and then extend that straight line into the first quadrant. Now after getting this slope represents every possible outcome of the problem we have at hand. Now from this, by looking at this slope, we will be able to visualize all the outcomes, and also we will be able to know the relationship between x and y. We saw that y is a dependent variable, right? And x is an independent variable. By looking at this graph, we will be able to find out how dependent y value is on x, how much, by what degree. Here in this equation, coefficient of y is 1 and coefficient of x is 0.5. If x is increased by 1, y will be increased by 0.5. So what this means is that y is dependent on x, dependent by 50%. This means that if x is increased by 100%, y will be increased 50% of that. Okay, you say if x is increased by 20, y will be increased by 10. Like this, when we represent an equation in a graph, we will be able to understand the correlation between each and every term in the equation. And finally, error term. When we are forming an equation, we will take some certain assumptions. Based on those assumptions, we will make an equation. We will form an equation. Based on that equation, we will represent whole scenario in a graph. Now, what happens when my assumptions and my actual result is different? Then we will introduce an error term into the equation. And that error term corrects any deviations between the actuals and the assumptions. Try to understand equations and visualize them in graphs. Okay. Now our equation is, after error term, y is equal to 30 plus 0.5 x plus error term. Now if you clearly observe this equation, this format, you would have seen this format in CA. If you are a final student, you would have seen this format in almost every equation in the financial management. Let's take an example of CAPM model. What is the CAPM model formula? Rx is equal to RF plus beta into RM minus RF. Now you need to be able to represent this equation in a graph. Try to represent whatever equation you see in the books in a graph. Then you will have a different perspective on the entire concept. Before representing it in a graph, you would have only, I think, 60% of the clarity on the concept. If you represent it in a graph and then analyze it properly, then you will get 100% clarity over the concept. Okay, try to do that from now.